Hello viewers, welcome to our YouTube channel Incredible Maths. In this video, we will solve a problem asked in CSIR June 2023 in part C. This question is related to calculus of variation. So here our functional or variation problem. So J involves two variables y of x and z of x. So therefore, here we will be solving a set of equation, that is set of differential equation to get a solution. So the Euler-Lagrange equation is given by fy minus d by dx of fy dash equal to 0, and another one is with respect to the other variable fz, that is fz minus d by dx of fz dash equal to 0. So now first we will find f. So f is equal to y dash square plus zz square plus y dash zs. So this is our f. So now equation 1. So let us name this as equation 2, and equation 1 implies, so fy, so there is no y, so 0 minus dy dx of fy dash, so differentiating this with respect to y dash. So we will find here, so fy dash is 2y dash plus z dash, and fz dash is z dash is 2z dash plus y dash. So minus d by dx of fy dash is 2y dash plus z dash equal to 0. So differentiating this, we will get 2y double dash plus z double dash equal to 0. And the second equation, so it is in this equation 3, and the second equation implies fz is 0 minus d by dx of fz dash is 2z dash plus y dash equal to 0. So this implies 2z dash plus y double dash equal to 0. So now we will find z dash here. So z double dash equal to minus y double dash by 2. So this is equation 4. Now substituting 4 in 3, so this implies 2y double dash minus y double dash by 2 equal to 0. So we have 4y double dash minus 1, so 3y double dash by 2 equal to 0. So this implies y double dash equal to 0. So y is c1x plus c2. So once we find c1 and c2, so we can find y. So the condition given on y is y of 0 equal to 1 and y of 1 equal to 0. Y of 0 equal to 1, so this implies 1 equal to c1 into 0 plus c2. So therefore c2 equal to 1. So therefore we can write y of x as c1x plus 1. So now second condition, y of 1 equal to 0. So that is 0 equal to c1 plus 1. So this implies c1 equal to minus 1. So c2 equal to 1 and c1 equal to minus 1. So therefore y of x equal to x minus x plus 1, or we can write as y is equal to 1 minus x. So similarly we have to find z. So here we will find z. So z dash is minus y double dash by 2. So y is 1 minus x, therefore y dash is minus 1 and y double dash is 0. So therefore z equal to c1x plus c2. Now condition on z is z of 0 equal to minus 1. So it is given here. Z of 0 equal to minus 1 and z of 1 is 2. Now z of 0 equal to minus 1. So this implies minus 1 equal to, so c1 into 0, 0 plus c2. So this implies c2 equal to minus 1. So therefore what is z now? So z equal to c1x minus 1. So we will use second condition to find c1. Second condition is z of 1 is equal to 2. Now z of 1 is equal to 2. So this implies 2 equal to c1 minus 1. So this implies c1 equal to 3. So therefore z is 3x minus 1. So this is our z and this is our x. So based on this y and z, so we are going to find the answer for this problem. So now the relation connecting y and z without x. So therefore we have to eliminate x from these two. So eliminating x, so we will get, so z equal to 3x minus 1. So from this we get x is equal to 1 minus y. X is equal to 1 minus y. So therefore substituting here 3 times 1 minus y minus 1 z. So z equal to 3 minus 3y minus 1. So therefore z plus 3y equal to 2. So this is one option, one answer. Z plus 3y equal to 2. Z plus 3y equal to 2. So this is correct and this one is wrong. So now we have to add these two, and that is we have to find y plus z. So adding y and z. So you will see what happens. Now y is equal to 1 minus x and z equal to 3x minus 1. So y plus z. Adding right hand side 1 minus x plus 3x minus 1. So these two will cancel. So y plus z equal to 2x. So this is another option. So y plus z equal to 2x. Y plus z equal to 2x. So this is correct and this is wrong. So therefore the correct option for this question is option A and option C. So if you like the content of this video, kindly like and share with your friends. Also subscribe our channel. Thank you.